Okay. Okay. Good evening, all. Let me start the session. And in today's session, we are going to discuss the solutions for engineering mathematics part for the mechanical engineering paper. And myself, Naveen Kumar, and I am pursuing my PhD from IIS Bangalore. And this is my short intro. And I have this 7 years of experience in GATE, teaching GATE students. Okay, so this is the first question, and I mean, I feel after seeing all these questions, what I felt was the engineering mathematics part was easy this time. Easy in the sense like the questions are not very tough. You have to have a basic understanding or basic level of math is enough for us to solve this problem. Even people who did last minute study of engineering mathematics would have been solved all the questions, not even one. I'm telling all the questions. Okay, so let's start the first question. So let's discuss a few 1 mark questions initially, and then we'll go for the 2 marks. So this question number 11 and all, right? So these are from the original GATE paper that has been officially released. You can check on your login and just you can see the same question number with same, if something are not matching, please try to check for this question. Okay, let's start. So the first question is from probability, right? Probability and statistics. So this is one of the important topic, but they have asked only 1 mark question, and that to a very, 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 very simple question. So let's read this question. A machine produces a defective component with a probability of 0.015. Okay, so let's write what is given, and then we'll discuss what they've asked. So they're saying that like they have given this probability. So we know that probability is denoted by P is equal to 0.015, right? And the number of defective components in a packed box containing 200 components produced by. So they have given you the distribution. So that is what is Poisson distribution. So we have already discussed in class. So Poisson distribution is one of the limiting case of binomial distribution. If you remember, binomial distribution has been derived from Bernoulli's distribution. So these are all point estimates, right? If you remember, these are all discrete distributions. If you remember, right? So Poisson distribution. So what was Poisson distribution? Okay, in side notes we'll write what is Poisson distribution. So Poisson distribution is denoted by how? P of x. Right, this is your distribution. Poisson distribution is right. E to the power of minus lambda x. Sorry, e to the power of minus lambda. 1 minute. E to the power of minus lambda into lambda to the power of x divided by x factorial if lambda is greater than 0 and x will be lying between 0 and infinity, right? This is the condition, or else it is 0. Otherwise, it is 0. That probability distribution is 0, right? So this is what is your Poisson's distribution. So this is your Poisson's distribution. Poisson's distribution, right? Good. Now. So what they're asking, let's see. Now we have written the Poisson distribution. We have been given with the probability. And what is this number of components, all these things? So here we have seen some value of, in Poisson distributions, they will give the value in which the components produced, the components failed. We have solved these questions in our class also, right? So here they're giving some n value. That n value is 200 components, right? That is what is the value of n. So generally, this n will have a definitive, definitely a very large number, and p will be a very small number, right? That is what we have seen, right? Now they're asking the mean and variance of the distribution. What a simple question it is, right? So in the properties of Poisson's distribution, so right, in properties of Poisson distributions, we have even seen that, right? The mean and mean. For every distribution, we have seen the mean and variance. So mean can be written as expectation of x, right? Or you can write it as mu, and the formula is lambda itself. What is lambda? I'll tell you. Lambda is n into p, right? Lambda is n into p, right? And variance variance can be written as V of x, or it can be written as sigma square, and that is also is n into p. So here in our case, they're asking mean and median. Mean and variance both are same. That's the reason why you see options. First three options are same. 3, under root 3, 0.15, 0.015. So all these things are same. Only exceptly right away we can discard this option number D, right? So why are we writing this n into p is equal to lambda, right? This lambda is nothing but a parameter of Poisson distribution. N into p, this lambda is parameter of Poisson distribution. Poisson's distribution, right? Right. And what is this? You know, what does this signify? It signifies. I mean, of course, we can see here it's signifying mean and median, but generally we can say it is signifying the mean of Poisson distribution. But let's not go into detail much. So this is what it is. The picture, you got the point. And in exam, you can solve it in 30 seconds if you know the formula. That is n into p. That's it. So here I can write mean is mu is equal to variance, that is sigma square, is equal to n into p. We have been given with both the values, that is n 200 into p, that is 0.015. Just multiply these things. It is 1.5 into 2. I think it is 3. See. So I can say lambda is equal to mean is equal to sigma square is equal to 3, and this is your answer. So option number A is the right answer. Simple, isn't it? Very simple. So this is what is here. This thing. Good. Next, this is also a very simple question. These are all kids questions. You might have done these things in your 10+2, right? 10+1 and 2. That kind of a question has been asked. What is that? Simply, in which the figure below shows the plot of function over the interval -4, 4. Which one of the option gives correctly identified function? So they're giving the options. So they have given this figure graph of the function, and they're telling us to find out the sorry. Let me go to the YouTube if somebody has joined. Okay. Fine. So they're telling to figure out the function. That's it. So let's forget about the diagram. Here in examination, you have to identify the right option. But as we are discussing the detailed solution part, so let's draw the function for each of it, right? So for option A, they're saying it as y is equal to modulus of 2 minus x. Before that, let's know what is y is equal to mod of x graph, right? So let us assume that we have y is equal to x, right? Y is equal to x. So what is y is equal to x? Y is equal to x is this, right? Y is equal to x is this graph. Okay, let me take a different ink here. Okay, so this is the graph, y is equal to x, right? But what they're saying, they have modulus. It means that modulus can never have negative value. So I'll just cut this, and I'll just do like this. So this is the modulus of x, y is equal to modulus of x. But they're asking 2 minus x. How do I draw this 2 minus x? So let me draw this. So we have this x and y. So you are shifting it by 2 minus x. This is shifting property, right? So you are just going 2 minus x. If x is equal to 0, y is equal to what? 2, right? If x is equal to 0, right, y is equal to 2. If y is equal to 0, x is equal to 2. So you have to put x is equal to 2 here, right? And then you have to start doing the same thing. So this is what is the graph, right? So this is what is the graph. So obviously that is what is not in the question. Now let's go for the option number B. In option number B, they're having modulus. Okay, y is equal to modulus of 2 minus mod x. Okay, so there are two modulus, right? First you have to draw modulus of x, right? First you have to draw the modulus of x, and then you have to invert it, minus x, right? Minus. So how does this minus modulus of x? So y is equal to minus modulus of x. graph will look like something like what is minus. Generally, y is equal to minus x is like this. So I'm just cutting it off this portion. I'm cutting this portion, and then I'm going to invert it like this. So this is the graph, right? Now I'm just shifting it with 2, right? I'm just shifting it with 2. In which direction I have to shift? In which direction I have to take? So it is, you have to substitute what is x is equal to 0. If x is equal to 0, then y is equal to 2, and y is equal to 0, x is equal to 2. Sorry, y is equal to 0, x is equal to 2, right? So it means that it is going on the y-axis. It is going on the y-axis. You have to shift like this. You have to shift like this. Then you'll come to here. So let's erase this stuff. Then I'll draw the graph. You'll understand what is happening, right? So let me do that like this, right? And now you have to draw something like this. But there is another modulus. So this is what I've drawn. But there is another modulus. So this part, whatever I'm drawing here, this part, this will cut off, and this will go into the positive direction. So that is what is your graph. Simple graph, and it is resembling to your question only. So from here itself, by here itself, you can say that option number B is correct answer. But let's proceed and do the other options as well. Okay. So the other options also similarly will make it. So option number C, what is that? Y is equal to 2 plus modulus x. You can try this. How do you? Just pause the video. You can try it, and I'm going to draw like this. It is going to shift in the. Anyone? Yes, it is going to shift upwards, but as it is not in the negative direction, there is no up and down. So this is what is the option, right? Good. And now D, option number D is y is equal to 2 minus simply modulus of x. If it is 2 minus simply modulus of x, so simply there is no, just here initially we have just drawn like this thing, right? After that we have cut it and we have gone in the positive axis. The same way you need to go to the positive axis. Simply draw like this. That's it. If there is another modulus, then this will go this side. That's it. So option number B is the right answer. Okay, that's a very simple question, and this also will not take much time if you are familiar with drawing graphs. And this graph things are very important for your interviews. If you're going for interviews for attempting for joining in any master's program in IIT or IISc, so they go, if there is an interview, sometimes some departments will not have interview, some departments will have interview. If you have interview, basically they'll ask this kind of questions, very simple questions. Okay, good. Next. Now, this also, by looking the question, you feel over what is given, but it's a very simple question. Okay, what is that? Let's read. A vector field B is x comma y comma z is equal to some xi cap by j cap minus 2z k cap has been given. Okay, now is defined over a conical region having a height h is equal to 2 and base radius. So here they have given height diagram h is equal to 2 and the base radius is how much? 3. Base radius is 3, and axis of z, along the axis of z as shown in the figure. Okay, figure is shown. The base of cone lies in xy plane. So this is xy plane. Obviously, you can see this is xy plane, and is centered at origin, obviously, and the n denotes the unit normal of the curved surface. At any point, the unit normal that they are saying is n cap of the cone. Now they are asking the value of surface integral of this vector with n dot n into ds. So just, it's a very simple question. Why it is a simple question? It is a simple question means they are asking this surface integral, and can you see this is some kind of a closed surface. This is a closed surface, right? This is a closed because you have bottom and there is a cone. It's a closed cone. As it is a closed cone, I can go for surface integral to volume integral by using, you can guess it, by using Gauss divergence theorem, right? Fine. So what is Gauss divergence theorem? Gauss divergence theorem. Gauss divergence. What is Gauss divergence theorem? It says if you have some function, f of x comma y comma z is a vector, scalar vector field function. So then if this function is there, then let us assume that as some, f bar, and there is some comma n, cap, that's a unit normal that is going out of that surface, pointing from that surface, unit normal outside. Then Gauss divergence theorem says, so I'll just write the formula here. Not is double integral surface. Double integral is denoted by this surface. Here they have given s, but it is double integral only. So it is f dot n cap or n bar ds is equal to, again that n bar only, right, is equal to triple integral. This is a formula. You have to remember this: volume over the volume of gradient of that function. Sorry, it's divergence, not gradient. Divergence of that function into t over volume. Right. So simply you can convert this into this volume integral and calculate it. That's it. And what is divergence? Divergence is nothing but, here in this case, divergence is denoted by div of f bar, or you can write it as dot f bar, right, is equal to, it is like dou by dou x I cap plus dou by j cap plus dou by dou z k cap into the function itself, fx, fy, fz, right? So I'll write it here. So it is f by x plus dou f by dou y plus dou f by dou z, right? Simple, very easy, right? Now let's convert this thing. So what they have asked? They have asked this thing, surface integral of p dot n ds. This is what they have asked. Simply convert it into volume integral. That is what is triple integral. Triple integral divergence of this b, right, into dv. Right. So let's calculate. What is b given? B given is this. That is, okay, let me write that. B is equal to x I cap plus y j cap minus 2z k cap. Okay. So let's calculate this thing. Then after that we'll integrate. Right. Triple integrate we have to do. This is what is dou by dou x of x thing, right? X plus dou by dou y of the y component, that is y, minus, because there is a minus, okay, let me write plus only, plus dou by dou z of minus 2z. Right? So what is this? What is this? It is dou by dou x 1 plus 1 minus 2, and that will be equal to 0. Right? It means that the divergence of the vector b, vector field b, is 0. It means that this triple integral, or the surface integral b dot n ds, right, is equal to triple integral b dot this thing will be equal to 0, because this value is 0 here. That's it. Simply answer is 0. Answer is 0. Very simple question. Next. Next is here. This question is from transformations. So it's a simple. I can say it is from some geometry. Okay, you can say it is from geometry. What is that? A linear transformation maps from x comma y in a plane from point x. Okay, what they say, they have some point, and they are mapping it to some other point using some transformation, and that transformation is this. Now, then in the first plane, in this thing, it has transferred it to another plane. Okay, transfer 2, and here it is a circle, and here what it is we have to know, because the disk is x square plus y square is plus 1, gets transferred into region. So what is that region? We are going to find out, and they're saying that this is this area. Maybe here the region is something different. Some different region has been transformed, and what they're asking the area of this region. That is a simple question they're asking. Okay, so let's try to solve that. Okay, that is what is the question. Let's try to solve. So what is that? So let's make the first region, that is x comma y plane, right? In that, what is that? It is given as x square plus y square is less than or equal to 1. In the sense, the region is inside, okay? Because it's a simple circle, right? With some inside, because it is less than or equal to 1 inside. Right? Now just it is getting transformed to x cap comma y cap, but they're giving some relation, right? What is that relation? From here I can say x cap is equal to 3y, right? So from there I can say y is equal to x by 3, x cap by 3, and y cap is equal to 2x. From here I can say x is equal to y cap by 2. Substitute in this equation, right? Substitute in this equation. What is x square? X square is y cap by 2, right? Whole square, plus y cap. Y square is x cap by 3 whole square, should be less than or equal to 1. So from here I can say this is an ellipse. This is an ellipse with major radius. Okay, let me rewrite this thing. That is x cap whole square by 9 plus y cap whole square by, right? So from here I can say this is an ellipse, right? Major radius value, major axis value is, I mean, semi-major axis value is, major axis value is 9, semi-major axis value is 3, and semi-minor axis value is 2, right? And let me draw the ellipse as well. So this is what is here, ellipse, right? With this, a is equal to 3, and this is b is equal to 2. It has been mapped to something, and the mapping I'm doing it here. Right? Now they're asking this area of the ellipse is equal to, you know, the area, it is pi AB. Just do it. Pi into 3 into 2. So it is simply nothing but approximately 18.8, some 4 units. They didn't give any units, so they're saying it is meter square, but they didn't say anything, so it is units, some units. Okay, that kind of simple question it is. Okay, next, this one. So the next is again a single mark question, that is they're asking from the complex numbers. So what is that? We have given this complex valued function, that is f of z is equal to minus kx into cos 2y minus I sin 2y, and which is analytic, right? Which is analytic, and where this is this. Now they're asking, now if the function is analytic, we have already discussed in complex numbers. If a function is analytic, it should satisfy one equation. CR equations we have discussed, right? That is called Cauchy-Riemann equations, right? So let's write that. If function f of z here is analytic, then it will satisfy Cauchy-Riemann equations. Cauchy-Riemann equations. This is our CR equations. What are CR equations? CR equations are nothing but, so we have to assume. So what was CR equations? If f of z is equal to, you know, it is u of x comma y. Remember, this was the basic fundamental equation, IV of x comma y. This is what we have discussed. In this case, it should be what? It should be Cauchy-Riemann equations are what? Dou u by dou x is equal to dou v by, sorry, dou v by dou y. This is one equation, Cauchy-Riemann. And another equation is dou u by dou y is equal to minus dou v by dou x. These were the two Cauchy equations, Cauchy-Riemann equations. So here, just compare these two. Compare these two. If you're comparing, what is that? You're getting u of x comma y, u of x comma y. You're getting it as e to the power of minus kx into cos 2y, right? And just compare v of x comma y is equal to e to the power of minus kx into minus, here minus is there, minus sine 2y. So take any of it, I'll take this, right? So for this you need dou u by dou x. So compare dou u by dou x. So dou u by dou x. Dou u by dou x is how much? Dou by dou x of minus e to the power of, sorry, e to the power of minus kx into cos 2y. So do this. It's using chain rule. You can do it. Is first you okay. No need of chain rule, because in the second one is not function of x. So simply differentiate e to the power of minus kx. Differentiation is minus k e to the power of x. So it is minus k e to the power of minus kx into cos 2y, right? And just do it dou v by dou y. So that is dou by dou y into minus e to the power of minus kx into cos, sorry, sine here, sine 2y. Okay. So that is, just differentiate the second term. Minus the first term will be as it is, right? The first term will be minus e to the power of minus kx into the differentiation of sine 2x. It will be cos 2y into 2, right? That is 2 into cos 2y. And these two are equal. These two are equal because of the Cauchy-Riemann equation, right? So let's write, that is dou u by dou x is equal to dou v by dou y. You can say k e to the power of minus kx cos 2y will be equal to minus 2 k e to the power of minus kx cos 2y. You can cancel off everything. You can cancel off everything. Sorry, here I think minus is left. Okay, you can cancel out everything and you'll get k is equal to 2. And that is the answer. They're asking what is the value of k only. Answer is 2. Okay, simple. Next. So this is from Laplace transform, and from here the questions are 2-mark questions. After that, question number 35, you are entering into the 2-mark question. And here also it is very simple. Let's do that. What is that? Simply they're asking the inverse transform, simple inverse transform. But the question, see, these are all basic questions. Okay, very easy, right? So let's do that. So what is given? So we'll write in the function as f of x is equal to x cube minus s. Simple trick here is to know simple one formula. What is the inverse Laplace of 1 by s minus a, 1 by s minus b, something like that you have to know. And also you have to split this partial functions. You have to partially split these functions, right? These fractions have to be split partially, because that is what you have to do, right? So what you have to do, this thing I can write as, right? Simply I can write as s. I can take s common, s square minus 1, and further I can write that as s into s plus 1 into s minus 1. Now you have to split. That is what is important. So already there's a trick that we have discussed in our class, right? The trick is nothing but, I'm just not going to mess up here. Simply I'm just going to write here. What will I do? I'll write here a by some s plus b by s plus 1, right, into plus c by s minus 1, right? And both the sides I'll multiply with this denominator. So what I'll do, this is 1 by s into s plus 1 into s minus 1. So I'll multiply here into s plus 1 into s minus 1. And this complete equation also I'll write here into multiply. I'll write as s into s plus 1 into s minus 1, right? All these things I'll do. And I've told you some trick as well, right? I told you some trick as well, which is very easy in this case. It's very easy in this case. What is that? So I can split it by, so let me write that. So let me write by s. If I'm writing by s, it means that s is equal to 0. Substitute that values in this 2 in this complete equation, but don't substitute here. Okay, 1 by 0, 1. Here also it is 1. So it means 1 by 1 is 1. So obviously 1 will come here, right? Oh, minus 1, sorry, because it is 0. If you, so don't substitute here, only s plus 1. So 0 plus 1 into 0 minus 1. Here it is 1, here it is minus 1 will come here. That's it. Plus 1 divided by, so numerator we should not write now only. Numerator we should not write now only. We have to write the denominator s plus 1. So instead of here you substitute s is equal to minus 1. So minus 1 minus 1. So minus 1 into minus 1 minus 1 minus 2 into minus 1 will be equal to 1 by 2. So this will be 1 by 2, right? Plus 1, sorry, here also I should not write the denominator, I should write the numerator. Numerator s minus 1. Again, you have to substitute s is equal to 1. So this is 1 into 1 plus 1 is 2, 1 into 1, 1, 2. So this will be again 1 by 2. That's it. You have split the partial things. That's it. Now they're asking what is f of s? F of s is equal to, I can write from here, it is minus 1 by s plus 1 by 2 into 1 by s plus 1 plus 1 by 2 into 1 by s minus 1. Now I want inverse Laplace. So Laplace inverse of f of s, right? That is Laplace inverse of minus 1 by s plus Laplace inverse of 1 by 2 into 1 by s plus 1 plus Laplace inverse of 1 by 2 into 1 by s minus 1. So if you remember, the Laplace of e power at is 1 by s minus a. Laplace, if you remember. So inverse is what? Inverse of 1 by s is e to the power of 0. Right? E to the power of 0 is 1. Right? So from here I can simply say that the Laplace inverse of this function is minus here. So I can write minus outside. So Laplace inverse of 1 by s is e to the power of 0. So it is minus 1 plus this is 1 by 2. I'll write outside. And Laplace inverse of e to the power of, so they're asking t, right? So e to the power of at, sorry, I'm sorry for that. So at, so here it is a is minus 1. So obviously, plus 1. So obviously I can say that the, okay, s plus 1, s minus 1, right? So this is minus 1. So this is e to the power of minus 1 t. So it is minus t plus half e to the power of t. See, this is what, see, if you are getting confused, this is Laplace inverse of e to the power of at is how much? Is 1 by s minus a. Laplace inverse of e to the power of a, e to the power of minus at is 1 by s plus a. So that is what inverse. So if you are wanting inverse, just cut this off, you write Laplace inverse here. Laplace inverse here. You'll get the answer. That's it. That is what I'm trying to do. Okay. So fine. So just check for the options. Whatever is right, that is the answer. So minus 1. That's it. That's it. So this is the answer. A. Simply A is the answer. Very simple. Okay. Good. Now, this is, I think, I can say this question is more or less from the calculus, where we have to find maximum and minimum, right? That is what we have to apply. Good. The question is the smallest perimeter that a rectangle with an area of 4 square units can have is. Okay. So they're saying what is the smallest perimeter with area. They have given the area, they're asking for the smallest perimeter. See, for a given area, you can have any perimeter. They're asking for the smallest perimeter, right? So first, let us assume a rectangle. There is a rectangle like this. There is a rectangle. Let's assume that the rectangle length is L. Okay. Okay, let's not take L. Let's take X. X and Y. That will be easy for us. X and Y, right? So I can say where X is length and Y is width of the rectangle. Right? Now what is the area of rectangle? Area is equal to x into y. What is perimeter? Perimeter is 2 into x plus y. This is the perimeter. 2 into 2x plus 2y is the 2 into x plus y is perimeter. So let me denote this perimeter with some p. Now I want this perimeter to be smallest. So minimize it. How do you minimize? I can differentiate this function with respect to, right? What do you say? With which parameter I have to derivate. So there are two things, x and y. So I have to derivate with respect to one, either x or y. So as I have area A here, and the area A is 4 square units, right? Area is 4. So I can say x into y is 4. From here I can say y is equal to 4 by x. I'll substitute it here. So perimeter will be converted into 2 into x plus 4 by x. Now I can differentiate. So for minimization, dp by dx should be equal to 0. Now I can say d by dx of this 2 into x plus 4 by x. Right? This will be equal to 0. From here. Now derivate. So this is 2 is outside. 2 into d by dx is 1 plus 2 into 8, 4. So this is minus 2 into 4, 8 divided by x square, right, is equal to 0. Right. So from here I can say 2 gets cancelled. So 2 if I take common, this is 2x square minus 4 is equal to 0, because 2 is 4 will be left, right? So from here I can say x is equal to plus or minus 2, but I will take x is equal to plus 2 because there is no negative length. Negative length of width is not possible, right? Only 2 is possible. So if x is equal to 2, then we can say y is equal to 4 by x, that is 4 by 2, that is 2. So y also is equal to 2. What is the perimeter? Perimeter is equal to 2 into x plus y, 2 plus 2, right? 2 into 4, 8. So there is no unit. What are units? 8 units. Answer is 8. That's a very simple question again. Right? Next. So next they're asking what is the oh, this question is very good question. And again, this is a very basic question. Just by looking at the equation, if you have attended the classes of any differential equations, people might have taught you. What is that? Consider the second order linear ordinary differential equation. So this is a simple homogeneous equation, that is second order. In that we are discussing the special case. We have discussed the special case, that was Euler-Cauchy differential equation. So this is Euler-Cauchy differential equation. Euler-Cauchy differential equation. So in Euler-Cauchy differential equation, we have done something, right? In the differential, say Euler-Cauchy differential equation is how it will look like. It is x to the power of n into to the power of n divided by, okay, let me write. It is x to the power of n, and the derivative of y with respect to x to the power of n plus x to the power of n minus 1, n minus 1 derivative of x to the power of n minus 1, right? So on, plus x dy by dx plus y is equal to sum of x. Something like that we have written. That is what is your Cauchy-Euler differential equation. Then what he did for converting this x to the power of n, we converted, because these are x to the power of n, right? So for converting that into constants, we have put x is equal to e to the power of t, right? That is what we have done. We have put x is equal to e to the power of t, if you remember, right? And after that, what did we write? We converted. We did some manipulations, and we told that d by dt is d. Then we told that and then we told if you have some x d by dx, then we can write it as d, right? And then if you're having x square d square by dx square, then we can write it as d into d1 minus d. So all these things we have seen, right? So just convert this equation. How do you convert this equation? So we have x square d square y by dx square plus x into d. This is very important. Don't forget this. Okay, this is where people will make mistakes here, right? This is dx minus y is equal to 0. So x square into d square y by dx square. So we have derived, sir. We have derived all these things in our class, if you remember, right? So this is what I can write as d into 1 minus d into the variable function value y plus x dy by dx. So we have x dy by dx. Simply we can denote it as, I think it is d. Yeah, this is d. D into y minus y. That's it. That's it. So this is what this complete thing is d into t minus 1. This is d. That's it. From here you can solve it as normal. This is normal equation, right? From here I can write d square minus what will I get? Dy, right? Plus d y minus y is equal to 0. From here I can write these two gets cancelled. D square minus y. Okay, 1 minute. Okay, okay. So I can convert this into auxiliary equation. I'm sorry. Okay, okay. I just skip that part. So I can write this as auxiliary m square minus m, right, plus m ys minus 1 is equal to 0. From here I can write m square minus 1 is equal to 0. And from here I can write m is equal to plus or minus 1. Right? So from here, as you got this thing, so I can write the solution, right? The solution will be in the form of y is equal to c1 e to the power of t plus c2 e to the power of minus t, because that is what is m values, right? We have general solution is c1 e to the power of mt c plus c to the power of c2 e to the power of minus mt, right? This is what I've written. So now they have given the initial values. What is that? Initial conditions. That is y at x is equal to 0, x is equal to 1 is 6, right? So I can say the these are called initial conditions or boundary conditions. So initial. Okay. Before doing this, here it is in the form of t, but I want to convert into the form of x. That is what is x, right? Because we have given y and x, not t. So this is where you have to convert. What is this? If x is equal to e to the power of t, then t will be ln x. That's it. Then t will be ln x. Okay. Then substitute here. C1 e to the power of ln x plus c2 e to the power of minus ln x, right? From here I can say y is equal to, sorry, from here I can say y is equal to c1 ln x is what, right? So I can e to the power of, this is x only, right? E to the power of ln x is x, and c2, this is 1 by x, inverse 1 by x, so this will be into 1 by x, right? Into 1 by x. So from here I can say the solution is c1x plus c2 by x. Okay. So now initial and or boundary conditions. Boundary conditions. Right. Initial or boundary conditions. What is that? Y at x is equal to 1 is equal to 6. Is equal to 6. Okay. So let's substitute here. Let's substitute. Y is 6. 6. X is 1. C1 into 1 plus C2 divided by 1. So I can say here C is equal to C1 plus C2. This is equation number 1. Another boundary condition is dy by dx at x is equal to 1 is equal to 2. So let's calculate dy by dx. That is d by dx of C1x plus C2 by x. Right? So let's do that. This is C1 and this is 1 minus C2 by x square. Okay, dy by dx. And the other condition is dy by dx at x is equal to 1 is equal to 2. So dy by dx at x is equal to 1 is equal to 2. So what is dy by dx? dy by dx is equal to 1 is 2 and dy by dx at 1, right? So C1 minus at x is equal to 1 divided by 1 whole square. So from here I can say that 2 is equal to C1 minus C2. Okay. If we solve this 2, what will you get? So C1, add these two equations, 1 plus 1 plus 2, C2 will be gone. 2C1 is equal to 8. So C1 is equal to 4. And of course, if we have 4 here, substitute here, so C2 is equal to 2. Good. That's it. You got the solution. Now they are asking what? The value of function at x is equal to 2. So what is the function now? What is the function? The function is, let me go down. The function is y is equal to C1x plus C2 by x. So you know C1 and C2, substitute. So here C, 4 into x plus C2 is 2 by x. But they are asking what? Condition at x is equal to 2. So at x is equal to 2, y is equal to 4 into 2 plus 2 by 2 is 8 plus 1 and that is 9. So answer is y is equal to 9. This is the answer. That's it. It's a little lengthy, but anyways, like this is what you have to do for the examination. Okay, simple question again. If you do not make any calculation mistake, and please do not forget, this is very important. People get often confused with this. This is where we have put this thing for converting the constant coefficients. Okay, converting into the constant coefficients, because the coefficients are variables, right? We are converting that into constants by putting some p. Very important. Good. This is the last question of math, and this also is from the numerical methods. So they're asking from this forward IR method. So what is that? There is initial value problem, that is dy by dt plus 2 into y is equal to 0, and initially there is the one condition, that is at y is equal to 0, the value is 1. Is solved numerically by forward IR method with a constant and a positive time step of delta t. Okay, let yn represent the numerical solution obtained at n. So yn is the solution obtained after n steps. The condition of modulus of yn plus 1. Then what is n plus 1? The solution obtained after n plus 1 steps should be less than the solution after n steps is satisfied if and only if delta t does not exist. So they're asking the value of delta t such that this condition is satisfied. Okay. So if you remember, what was our, we have these 4 methods. If you remember, we are solving these 4 methods, like there are this numerical methods, right? Like Euler method, then forward Euler method, then the modified Euler method, then Runge-Kutta, third order Runge-Kutta, all these things we have discussed, right? So what is that? So I'll write the formula. That is, if you have the function as dy by dx is equal to some f of x comma y, something like that, then the solution at I plus 1th step is equal to solution of ith step. This is for forward Euler method, right? I plus some h, that h is your time step delta t here. In this case it is xi comma yi. Right? So this is your forward Euler method. Forward Euler method. Okay, so with this we'll start our problem. Okay, so what is given? Dy by dt. Instead of x they have given t, that's it. Okay, plus 2y is equal to 0. So from here, and also they have given at y is equal to y at y of 0. This, what does this mean? What does this mean? This means that at t time 0, time step 0, right? T naught at t naught 0, then y naught will be equal to 0. That is what is given. That is what is the meaning of it. Okay, so dy by dt. So here I can say dy by dt is equal to minus 2y, right? So here I can write the function as dy by dt is equal to I can say this is some kind of a t is not there, but I can write as f of some t comma y. I can write like this. Okay, good. So now who is this zz? Any doubt, guys? Okay, fine. So from here I can say that n plus 1th step is equal to nth step plus some h into f of tn comma yn, right? Please remember this is h is equal to dt, that is our time step. Good, right? So now y of n plus 1 is equal to y of n plus this is dt. And what is the function? What is the function at nth? This value is function, that is minus 2y, but at nth is minus 2y n. That's it. So from here I can say y of yn plus 1 yn minus delta t or 2 delta t into yn. Let's go to the next slide. Let's copy that. Y of n plus 1 is equal to y of n minus 2 delta t y. From here I can take yn common. Yn is 1 minus 2 delta t. Okay. Now they're asking the moduluses, not the normal. So I'll apply modulus on both sides. So modulus of y of n, right, is equal to modulus of yn. Okay, before that I'll do one thing. I'll just divide these things. Right? So y of n plus 1 divided by y of yn is equal to 1 minus 2. This thing. So now I'll apply modulus. I'll apply the modulus. Once I apply modulus, what is that they are saying? In this question, they should be less from the condition given. What is given? What is given? That is modulus of this thing should be less than or equal to what? Y of n. Right? From here I can say y of n divided by this thing will be equal to less than 1. From here I can say less than 1 from given. Right? So from here I can say modulus of 1 minus 2 delta t should be less than or equal to 1. So if you remove the modulus, this will be plus or minus, right? So I can say that minus 1, this is 1, right? Minus 1 less than or equal to the middle value minus 2, 3, no modulus now, less than or equal to 1, right? So just add subtract 1 on both sides. So if you subtract minus 2 here, subtract, this is minus 2 delta t less than, subtract minus 1, so 0, right? Now, if you remove the minus signs, if you reverse the minus signs, this will be 2 greater than 2 delta t greater than 0, or else I can write it as 0 less than or equal to 2t less than or equal to t 2. From here I can say 2 will get cancelled, so 0 less than delta t less than or equal to. Now what is the question they have asked? Delta t should not exceed. It should not exceed, the maximum value is 1. So it should not exceed 1. So dt should not exceed 1. That's it. The answer should be 1. You have to put 1 as answer. That's it. So this answer is, that's it guys. So that's the thing. That's a very important session on maths. If you have any doubts, please post it in the comments, and I would like to discuss any thing that you are asking in the comments. Okay. Thank you guys. Have a nice day.